Good evening, gents, and welcome back to another equations video where I hopefully will unpack a bit more of the equations that we have to learn and learn how to balance in this topic of atomic structure part 2. So, we went over MASH last time, and now we're going to go over McAWSaC. Remember, Richie McCaw, the legend, All Black captain, Richie McAWSaC. Remember that, and you remember this equation. Simple as that. Okay, enough of that. So, McAWSaC, what am I going on about? McAWSaC. So, McAWSaC is the anagram, just like MASH was, of this type of equation. So we have our muck, which is the metal carbonate. So a metal bound with a carbonate ion. Okay, and this is added to an acid will cause a reaction. We've seen that in the lab. We've seen the fizzing. We've seen what happens. Okay, so McAW, the A, muck, A is the first part of the word, and the W is a new one, but a molecule you all know very well that we are basing this whole topic around. What is water? Water is made in this equation. You take a metal carbonate and put it in acid, you actually get some water out of it, which is pretty amazing stuff. So, we're going to plus that to some Sa. Okay, some Sa for salt. So we've got McAWSaC. Okay, McAWSaC comes when we see the gas, and that gas is one again you all know. Okay, and that gas is carbon dioxide. Okay, so McAWSaC. All right, what does that look like in real life? Well, let's use a slightly different metal this time than magnesium, because we're probably sick of magnesium. Here it is. It is zinc. Okay, we're going to add some zinc into our little test tube here. Zinc is a group 2 metal, just like magnesium was, positive 2 charge. Okay, and we're going to add this to the zinc, some carbonate. So we've got some zinc carbon 8. Now remember the cheeky way I taught you how to remember. It's not carbonide or carbide or anything like that. It's carbonate, oxygen. It's with some mates. It's got some mates there, oxygen mates. Okay, and we're going to keep it simple. We're going to positive. We're going to add this to the acid we all know and love. Bit of hydrochloric acid there. Okay, bit of hydrochloric acid. All right, so we've got some zinc carbonate, metal carbonate. We've got some acid in the form of hydrochloric acid. All right. Now, where do we go next? What does it make? Water. So if you see a carbonate, this bit here, this ion, if you see that, and you see one of the acids, nitric acid, sulfuric acid, hydrochloric acid, you need to know makes water. Okay? Water. Water, you should know, is H and O. Not hydroxide, but H2O. Alright? Water, H2O. Alright, you should know that by now. If you don't panic. That is water, know it. Alright? Now we're going to add that to some Sa, some salt. Okay? Now remember the rules for salt. If we've got an acid here, the metal, usually more reactive, is going to kick that hydrogen out. Alright? Kick that hydrogen out. So the metal is going to kick the hydrogen out, and it's going to bind with the leftover chloride. It's going to bind with the leftover chloride. So it kicks the hydrogen out, binds with the leftover chloride, and we have zinc chloride. No oxygens here, nothing else bounded to it, so it's not, you know, it's not carbonate or chlorate. Okay, and then we're going to plus this to some carbon dioxide. Okay, some carbon dioxide. All right, over here. Just jimmying around with my things here, didn't print off enough, write up enough CO2s. But anyway, CO2, you can see that there. So carbon dioxide. So, pretty straightforward. We've got our metal carbonate and zinc carbonate here. Our acid is hydrochloric acid. Okay, those are our reactants. We've got our products over here, water, H2O. We've got our Sa, our salt, zinc chloride, and we've got our carbon dioxide. Okay, so now remember my tip. We look at each compound or element individually, check that it's balanced, and then move on. Okay, so zinc carbonate, zinc Group 2 metal. Group 2 means it's got 2 electrons in its outer shell that it wants to get rid of and becomes more positive. Okay, it's down the bottom there. Will bind with this ion here, and this ion is in the -2 column. What does that mean? That means that they're going to be balanced. 2 positive, 2 minus, it's going to make 0. They're bound. It's good. We're happy. Hydrochloric acid, as from before, hydrogen positive in the first column here, chlorine, second one down there. Going to bind with the hydrogen, no problems. Okay, 1 and 1 cancel out, 0. Water here, okay, this molecule here, you could do a quick little balance, but we know this is how it's found in nature. But just to double check yourself, 2 hydrogens and an oxygen in the second column. 2 hydrogens means 2 plus, the oxygen is 2 minus, that's why we only have 1 of them here. They cancel each other out, 0, that's a happy bonded molecule. Going to zinc chloride now. Zinc, number 2, 2 positive, but we know chlorines, they're only -1. What do we do? What do we do, gents? You tell me. That's right. I hope this is what you said. And put the little 2, because we're looking at each individual little compound by itself. You know, double the amount of chlorine there, so we get double the amount of negative charges, which means we can cancel out the 2 charges here. Okay? Zinc in the second column, chloride in the first. We need 2 of these to cancel out 1 of those. Okay, hopefully we've got that. Now, carbon dioxide. Remember that what I told you about carbon. Carbon loves to bind with lots of things, and it does some interesting bonding with oxygen. You might only see 2 there. Carbon has 4 free electrons. Oxygen has wants to gain 2, so it bonds with 2 of those, and we're fine. But you're not given carbon on here. Just know that carbon dioxide is balanced as it is, CO2, the common way we find it in nature. So, balanced, 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 balanced. Right, now we're going to look at the big picture, this whole equation, which means we can now ignore the little numbers, we're going to use the big numbers. Okay, balancing big. Zinc, carbonate plus hydrochloric acid. Let's look at what goes into our equation. 1 zinc in as a reactant, 1 zinc out as a product. Zinc is okay. Carbonate. Now we can usually look at the ions together. Okay, carbonate here, going in. Oh, hang on, can we look at it by itself? No, well, there's no carbonates here, we've got carbon dioxide. And, okay, so let's break it down. 1 carbon going in, 1 carbon going out. Pretty good. 3 oxygens going in. You can tell that by the 3 here. 3 going in. Where's the first one there? Yep, 1 here. And 2 down there. 3. So, we've got this right amount of zincs going in, with the right amount of carbons going in, we've got the right amount of oxygens going in. Good. Okay, let's look at hydrogen. Hydrogen going in, 2 hydrogens coming out. Alright, that's not great. Let's have a look. 1 chlorine going in, 2 coming out. Okay, not great again, but simple fix, isn't it, gents? If we've got double the amount coming out this end, we have to have the same amount going in. Now we can't do what we did with what you saw me explain with the mass reaction. We can't put those little 2's here. We have to put the big numbers to double this molecule, because this molecule is happy as it is. We can't keep adding extra stuff to it. Alright, so make a little bit of room here, and we're going to add that big 2. Okay, the big 2 here. Oh, shoot off the positive there. Let's add it in so it's not one giant molecule. Positive there. Okay. So, zinc carbonate plus 2 hydrochloric acids makes H2O water. Zinc chloride as our salt, and carbon dioxide as our gas. McAWSaC reactions, guys, metal carbonate reactions. The carbonate will always produce a carbon dioxide gas. If you can remember that, you'll be doing well. If you can get to this stage, I'll be super impressed. Okay? Don't panic if you can't. Just keep trying. Practice makes perfect with these guys. It's like maths. Okay, you do lots and lots of maths, you could do it well. Okay, so just to give you a bit of a challenge, fellas, try it with a group 1 metal. So I'm just trying to look for one. Try it with a bit of sodium. Okay, see what happens. What do you have to change? What do you have to rearrange? All right, follow the pattern. Maybe change it up with some of the acids that we use. Maybe react it with some H2SO4. So I'm just trying to find an extra 2. Maybe react it with some H2SO4. Sulfuric acid. Even react it with a little bit of, if I can find one. Oh, I used it over here. A little bit of nitric acid. See if you can go nitric acid plus maybe sodium or zinc or magnesium. Try those out. Do all those combinations. See if you can balance those ones. Because there's only so many that we can quiz you on. Alright? Hopefully that made a bit of sense. Keep watching this video if you're not too sure. Always have your table of ions handy. And my top tips are balance small first. Learn these things like H2O and CO2 off by heart. Okay? And just take it slow. Draw your table of what goes in and what comes out as well. That always helps. And just keep practicing. Keep practicing, keep practicing. I'll give you some more practice in class next. Alright, enough rambling from me, fellas. Again, I hope this was a good video for you to learn how to do equations. I'll see you in class. Study hard, get those pages done. I'm out.